The first question that comes to mind when creating a Kubernetes cluster is, what is the right sizing for worker nodes? Let's take an example. For a required capacity of 32 cores and 64 GB RAM in a cluster, shall we create only one large worker node with the required capacity? Shall we create 4 medium worker nodes with 8 cores and 16 GB RAM, or 8 small worker nodes with 4 cores and 8 GB RAM? All options have the same capacity, but what is the most efficient from capacity and business case point of views?
To understand worker node's capacity consumption, we need to understand how the worker node is built of. The main component of a worker node are operating system, Kubernetes as a main node agent, system pods, such as core DNS, CNI, and finally applications pods. Kubernetes plays a major role in maintaining pod state running and healthy and in sync with pod specifications. Kubernetes malfunctioning can impact severely pod lifecycle management on the worker node. Now let's talk about system and Kubernetes utilization. From practical experience, the CPU and memory consumption for the OS and Kubernetes is estimated as follows.
For CPU cores, OS and Kubernetes consume 8% CPU cores for the first 4 CPU cores and consume 1% for each following 4 CPU cores.
For the memory we have 1 GB consumption in 4 GB RAM, 1.8 GB consumption for a capacity equal or less than 8 GB RAM, 2.6 GB consumption for a capacity equal or less than 16 GB RAM, 3.3 GB for a capacity equal or less than 128 GB RAM, and 3.5 GB consumption for a capacity equal or less than 256 GB RAM.
Now let's go through our exercise. We suppose that we want to deploy 8 replicas of a pod that require 2 CPU cores and 4 GB RAM. For the sake of the exercise, we need to make sure that the pods fits in the large worker node, 32 CPU cores and 64 GB RAM, and small worker nodes, 4 CPU cores and 8 GB RAM. Let's start with large worker node. The 8 replicas will require 16 CPU cores and 32 GB RAM. The OS and Kubernetes will require 8% for the first 4 CPU cores, plus 1% multiplied by the 7 blocks of 4 CPU cores, which make it a total of 15% of the CPU core's capacity. The Kubernetes and OS required capacity will be 4.8 CPU cores and 3.3 GB RAM, considering that the RAM is less than 128 GB RAM. We should also consider eviction threshold. The eviction threshold is used by the Kubernetes to evict pods from the worker node once this threshold is exceeded. The recommended value for the threshold is 10%, which is 3.2 CPU cores and 6.4 GB. Totally, we will have 24 CPU cores and 41.7 GB RAM. Now let's take the 8 small worker nodes. Each node will carry 1 pod. Each pod will consume 2 CPU cores and 4 GB RAMs. OS and Kubernetes will consume 320 millicores and 1.8 GB RAM. 10% of the worker node capacity will be dedicated for eviction. The needed total capacity is 2.52 CPU cores and 6.6 GB RAM. In both cases, the pods will fit within the small and large worker nodes. The large worker pod still have enough capacity for 3 new pods, while the small worker nodes don't have any more capacity for new pods. From high availability point of view, it is obvious that small worker nodes are better. From cost point of view, taking the example of Google Cloud, 8 small worker node cost $1,238.32 USD monthly, and large worker node costs $1,231.32 USD, which almost the same price. If the application requires scaling 3 new pod, 3 new small worker node need to be created, which will cost additional $471 USD per month, and in large worker node option, it will be for free.
The previous comparison is appropriate for IT cloud. Telco cloud environment have different and stringent requirements in terms of availability, eviction, system consumption, and throughput. Telco Cloud requires running DPDK in user space inside application pods. System and Kubernetes requires more capacity due to the required device plugin, CRAO VCNIs, node discovery feature, topology manager.